All right, let's take a look at the next part of chapter 2. In this section, I had described how all the transformations worked. So adding and subtracting on the outside shifts up and down. Adding and subtracting on the inside of the function like this, moves it left and right. Multiplying on the outside, a vertical stretch, if it's bigger than 1. If it's inside, it's a horizontal shrink if it's bigger than 1. Negative on the outside reflects vertically across the x-axis. Negative on the inside reflects horizontally across the y-axis. So now, let's finish up some of these practice problems. Number 5 here, it says, given a function, f of x, describe how g of x would be obtained from f of x if g of x is equal to this. In other words, what would we do to this graph to get this graph? And if you look at them, you'll see some similarities, right? There's the 5s in both places. We see the x cubed in both places. I guess that's where the similarities end. There's some on the outside here, right? One I'm adding, one I'm subtracting. So it's going to be the same shape. We just need to shift, right? So we need to move g of x. So if we have f of x, we need to move with this plus 3. What's that going to do? It's going to move left 3. So we're going to have to move f of x left 3. And so that takes care of this plus 3. And then here, this was shifted up 1, and now it needs to shift down 2. So that's a difference of 3. So we're going to have to take f of x and move down 3. So move f of x left 3 and down 3. All right. Now we need to write an equation that matches the criteria here. So it's the shape of y equals square root of x, but reflected over the y-axis. So this is y equals square root of x. They want us to reflect over the y-axis, so it ends up over here. So it's reflecting horizontally, so that's going to be on the inside. So I know I want a negative x. And shifted down 3. How do we move it down 3? Well, that's on the vertical direction. It's going to be on the outside. We need to put plus 3. Excellent. All right, number 7. Shape of y of 1 over x, but shrunk vertically by a factor of 3. So a vertical shrink up and down, it's got to be less than 1. So factor of 3 is going to be 1/3. And left 2. How do I move left 2? If you remember its opposite, I'm going to have to add 2 on the inside. So this ends up being y equals 1/3 times 1 over x plus 2. So the times is on the outside. That'll be a vertical shrink by a factor of 3. Plus 2 on the inside will move it left 2. You could also multiply this and get this. Either one of those would be acceptable. The last one, shifted up 1 unit. How do I shift up 1? I just on the outside add 1. All right. I'm going to call number 9 enrichment. If you want to do it, great. I'll talk through it, but you can also skip ahead in the video if you'd like. The key again is just identifying what's going on. Okay, so minus 2 on the inside is going to go right 2. Plus 1 is up 1. So all I have to do is move all of my points right 2 and up 1. Right 2, 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 up 1. You're getting tired of this, aren't you? Right 2, up 1. And then just connect the dots. you'll notice it shifted the whole thing right 2 and up 1. Here, times 2 minus 3. What's that going to do? Vertical stretch by a factor of 2 times 2, and then subtract 3. You can do this on the graph and think, okay, this y value is 5 times 2 would give me 10, and minus 3 would end up here. That works fine. You could also do it on the table. If I take 5 times 2 is 10, minus 3 gives me 7. 2 times 1 gives me 2, minus 3 is negative 1. Negative 1. Negative 2 times 2 is negative 4, minus 3 is negative 7. Negative 9, negative 7, and negative 1. Here we go. I can now just plot these points. Negative 3 has a y value of negative 1. Negative 1. At negative 2, it's actually going to be negative 7. Negative 9, negative 7, and negative 1. And you see that this has been stretched in the vertical direction times 2. It's also been shifted down 3, but with that stretch, sometimes it makes it look like it went up, like right here. All right, we can do the same thing here. This is going to reflect it horizontally and then shift it up 3. I think this might be easier to do without the table because the x values are changing as well. Here we go. We've got negative 6, so it's going to flip this all the way over to positive 6, but then it's going to go up 3. So now we're up here. This one's going to flip from negative 3 to positive 3 and then shift up 3. Don't need that. This one, oops, not what I wanted. This one is going to reflect across the y-axis over to here and then up 3. Instead of positive 2, this will be over to negative 2 and up 3. This, instead of positive 3, will be negative 3 and up 3. Instead of 4, it'll be negative 4 and up 3. And instead of 5, it'll be positive 5 and up 3. So that's a little confusing. I'm going to erase these. I feel like I should have crossed that one off. Here we go. Looks something like that. Again, this is really just enrichment here. Challenge, you might call it. 1/3 on the inside. What's that going to do? Horizontal. You might be tempted to say shrink, but it's a horizontal stretch by a factor of 3. So everything's going to be 3 times farther from the y-axis. So instead of being at negative 6, this is going to be at negative 18, which is going to be like way out here. Instead of being at negative 3, it's now going to be at negative 9. Instead of being at 1, it'll be 3 times farther at 3. Instead of being out 2, this one will end up being out times 2 to 6. This one will end up being out times 3, which is 9. This one here, instead of 4, will be 12. And instead of 5, we're looking at 15. So you get the idea. This is really stretched out in the horizontal direction. Something like that. All right. Let's take a look at section 2.2.